The last modeling specific topic that we're going to be discussing in this course is about slaving constraints and how we apply slaves and master joint constraints to our model. So the concept behind this is basically we'd want to constrain multiple disconnected joints to one another, but we may want to do it in just a specific set of degrees of freedom. So we'd specify a master joint and several slave joints, and we constrain those slave joints to the master joint in whatever degrees of freedom we felt necessary. And what this means is that those slave joints will share the same displacement as the master joint in whatever degrees of freedom are slaved. So if we just slave joint A to joint B in the X translation direction, whatever X translation joint B has, joint A will also have, but they can maybe translate independently of one another in the Y translation direction, for example. Let's look at an example of this right now. Here we've got a simple frame with some bracing that's we've defined to only resist lateral loads. If we look at this a little bit closer, we can see that we've got a joint connected to the member here with the bracing attached to it. These braces are truss members, so they only support axial load. And if I go to the loads window and I toggle on the display of our loads here, I can see that we have some gravity loads, or vertical loads, and some lateral loads as well. And if we run the analysis, click Run, Analyze, and run a linear static analysis, we can see that the analysis runs fine. But when we look at the deflection diagram, and maybe I'll look at this head on so we can see it a little bit better, clearly there is some influence from this bracing to resist some of the vertical loads. And that's not really what we had in mind. So we would need to consider maybe using slave joints and a master and slave relationship to get this to work the way we want. So I'm going to go to the geometry window, and using the joint tool, I'm actually just going to right click on this joint here, the one at the middle of my beam at the top of my braces. I'm going to right click and I'm going to go to properties. And this is going to bring up a mini spreadsheet with all the information I need to really understand this joint. You can see that the Z coordinate is at 4 meters. I'm actually going to move it down slightly so that it's not physically connected to this member. So I'm going to move it down just 0.2 meters to 3.8 meters. And now you can see that there is a physical separation between this joint at the top of our bracing and the beam itself. I'm also going to add another joint at the middle of the beam here. So I'm going to left click with the member definition tool, just like I did in previous exercises, and I'm going to add a joint at the midpoint of that member. And you can see here now it's added that joint and it's asking me to define the second point of this member, but I'm just going to press escape to end the command, and now it's just left me with that one joint. And the final step for this process is to specify the slave and master joints. So I can use the slave tool, but it would certainly help that I understand which joint is which. So I'm going to toggle on the display of my joint numbers in the status bar at the bottom of the screen. I'll press this button to toggle on, and we can see that the joint at the top of my braces is joint number 5, and at the middle of my beam that's joint number 6. So I want basically these two to be constrained to one another. So I'm going to specify joint number 6 as being the master joint. I'll say that master joint is joint number 6, and I'm going to slave it in the X translation direction. And I'm going to left click joint number 5 here to slave that joint number 6 to joint number 5 in the X translation direction. You notice it has this little arrow in the X translation direction showing me that it's slaved to joint number 6. So any X translation that joint number 6 has is going to also be applied to joint number 5. And I'm going to do the same thing here within the Y translation degree of freedom as well. I'm going to keep the same master joint, and I'm just going to left click on joint number 5. And now we've effectively modeled a sliding connection where these two joints can translate independently of one another in the vertical direction, but in the lateral directions, they will basically have the same translation. So they are slaved together in that sense. Now I'm going to go ahead and run the analysis again. Run a linear static analysis. Once again, we get a clean solution. But now if I look at the deflection, I can clearly see that the two joints there are effectively translating independently of one another in the vertical direction. But in the lateral direction, they have similar deflections. So if I look at dx, for example, I can see that we have 0.78 millimeters for both joints. But if I look at dz, I can see that I don't actually have any displacement at the top of my brace, but I have 2.5 millimeters at the middle of my beam. So this allows you to achieve different connections and constraints that you might not necessarily be able to do if the two members were connected in the traditional sense.